Thus far, we've talked about elasticity of demand. I should say price elasticity of demand. We've talked about how it's calculated. It's just the percent change in quantity divided by the percent change in price. And what we're trying to figure out is for a 1% change in price, how much does quantity change? That's it. It's a measure of sensitivity. All right, so let's take a look at this and see what it looks like. That's a graph. A demand curve that looks like that has an elasticity of 0. How come? Well, the price goes up from P1 to P2. Quantity goes from Q1 to Q2. Okay, it doesn't change, as you can see. So, for a 1% change in price, the percent change in quantity is 0. So that's a perfectly inelastic demand curve. Now, the other end of the spectrum, a demand curve that looks like that is perfectly elastic. That's infinite elasticity. For a teeny tiny, change in price, we've got just, an infinite response in demand. So we've got perfectly inelastic, perfectly elastic. Now, what have we got in between? In between we have, well, a curve that's quite steep. This would be relatively inelastic, or an elasticity that is less than 1 for the most part. And I'll talk about that, why I said for the most part. So a figure in a minute. For a demand curve that's pretty steep like that, that would be inelastic. Not perfectly inelastic, but inelastic. And a curve that's like that would be an elasticity greater than 1, or relatively elastic. I'll spare you my handwriting. Relatively elastic. Okay, not perfectly inelastic. It's greater than 1, but certainly not infinite. And if you want to see what a unitary elasticity curve looks like that. The elasticity is equal to 1. So at any place along this curve, the elasticity is 1. Now, why is it shaped so funny? Well, let's talk about that right now. Even though these demand curves, this one's elastic for the most part. Okay, this one, inelastic for the most part. This was elastic for the most part. The thing is that every demand curve will have a part, every linear demand curve, not this one, okay, and I'll show you, has a portion of it that is inelastic, unit elastic, and elastic. Okay, so let's take a look. Okay, there's a demand curve. Nice linear sloping down demand curve, law of demand. Down here at the bottom would be the inelastic portion of the demand curve. Up here at the top is the elastic portion of the demand curve. And somewhere in the middle is the unit elastic part of the demand curve. So as we move up the demand curve, it gets more and more elastic. So as prices rise, the elasticity increases. Now, why is that? Well, let's think about this. Let's say we're dealing with table salt. And salt is, you've got these, things of salt that you get at the store. And I don't know what they cost. I mean, it used to be like less than $1 for like a pint of salt or whatever. It's pretty cheap. So let's say salt goes from $1 to $1.10. $1 to $1.10. Now let's just think about this intuitively. Are you even going to notice? I mean, I know I won't. I'll throw my salt in the cart, and that's going to last a while. Okay, this salt, this little thing of salt, how long does that last a household? Well, I don't know. Several weeks, if not months. I guess it depends on how big your household is, how much you use salt. But I mean, it's going to last a while. It's not going to break the bank when you buy new salt. So if the price goes from $1 to $1.10, that's a 10% increase in the price. How much are you going to cut back on your salt purchases? Probably very, very little, if at all, if you even notice. So if price goes up 10%, quantity demanded is going to fall far less than 10%, right? So the percent change in quantity, percent change in quantity divided by the percent change in price. This is 10%, and quantity demanded is going to fall not very much, far less than 10. Let's say 1%. Okay, I mean it's gonna, barely. So that's a highly inelastic good at that point. Okay, let's say now, let's go up here. Let's say we're starting here, and the price of salt goes up to here. Let's say it's $100. Salt is $100, and it goes up to $110. Do you notice? Well, yeah, you're going to notice if something goes from 100 to 100. First of all, you're going to notice it's 100, all right, if you're still even buying salt. But see, now, because this good is taking on a bigger proportion of your budget, and that's one of the determinants of price elasticity of demand. We'll talk about in a minute. But now that it's occupying a bigger portion of your budget, you're more aware of prices, and you're more aware of price changes. So, if you're still buying the stuff, okay, you're being very careful. So, at that point, we may very well see something. Again, I'm just making up these numbers. We may see something like this, where now, before it was less than 1, elasticity was less than 1 down here, down there on the demand curve. Up here at higher prices, that inelastic good has become an elastic good. Okay, so where you're using it very carefully, you're figuring out every possible way to reduce your consumption of salt. Up here, down here, you're spilling it on the floor, and who cares, right? So that's a linear demand curve. You're going to start out at low prices. It's going to have at least a portion that's inelastic. and a portion that's elastic. Unless it is perfectly, unless it's like this, perfectly elastic or perfectly inelastic. You know, this is elastic, infinite elastic everywhere along the curve. This is perfectly inelastic, or elasticity of 0 all along the curve. But as soon as we break away from that, if we have a really steep demand curve, most of that demand curve, most of it, you know, we're going to have to go way up here. Most of it's going to be inelastic, but it will have an elastic portion way, way up here. Okay. Now, I'm going to show you graphically. Okay. I showed you intuitively. You kind of get it intuitively. At low prices, you know, the price changes aren't really on your radar, and so you don't change your consumption that much. It's inelastic. High prices, the prices are on your radar, price changes are on your radar, it's occupying a bigger proportion of your budget. Yes, you're going to be more sensitive to those price changes. Now, I'm going to show you how this works, a little bit, at least a graphical, a semi-mathematical demonstration of that. Let's say that the prices go from P1 to P2, okay? There's Q1. There's Q2. Okay. Now, as you know, price times quantity equals total revenue. And as you know, length times width is equal to the area of a rectangle. Well, what is length times width? Here, it's just price times quantity, right? Here, we've got the length, and here we have the width or the height, okay? So what we're going to do is find the area of these rectangles. Let me change colors here. I should have thought ahead. This is my chance to demonstrate my artistic talents. Well, because the price went up from P1 to P2, revenue gained from that price increase is this area, this rectangle. That's because price went up. However, because the price went up, quantity went down. Because quantity goes down, they lost that amount of revenue, that area. Okay, so price goes up, they gain all this, but quantity goes down and they lose this. Which rectangle is a bigger? Pretty easy to see. So what we've got here is price goes up and total revenue goes up. And that means if price and revenues go the same direction, that means elasticity is less than 1. Remember? Here, let's review that. Percent change in quantity divided by the percent change in price. If the elasticity is less than 1, we know the denominator has to be bigger than the numerator. That's how you get a number less than 1. Therefore, price is going to be the bigger effect here than Q. That means this is going to dominate, and you can see that it does. The revenues go up. by more than the revenues fall because quantity falls. Okay. Let's go up here now. Let's say we're starting here and price goes up from P1 to P2. Here's Q1 and P2. There's Q2. Okay, what we've got now is because the price went up from P1 to P2, there was an increase in revenue of that rectangle. However, because quantity fell from Q1 to Q2, there was a loss of revenue of this rectangle, which is bigger. Okay, it's pretty clear that because quantity fell from here to here, that this is obviously the loss in revenue due to quantity falling is bigger than the revenue gained from the increase in price. That means it's elastic. Okay? It's elastic. Price went up and people shifted away. They bought something else. So we had price going up and we have revenues going down. That means that elasticity is greater than 1. And for elasticity to be greater than 1, that means the numerator has to be bigger than the denominator, right? So Q is dominating. And that's what we see. Q is dominating. Look at all that. Okay, now here's why I make the big bucks. See if I can do this. Let's see if I pick the right spot. Say price goes from P1 to P2. It's Q1. Oh, yeah. And here's Q2. Okay. Well, let's pick a different color. Because price goes up from P1 to P2, there is a gain in revenue of this rectangle. But because price went up, quantity falls from here to here. And the loss in revenue, because quantity falls, is this rectangle. And as you can see, this rectangle is exactly the same as that rectangle. So the revenue gain from the price increase is the same as the revenue loss from the quantity decrease. What does that mean? That means elasticity is equal to 1. So down here we have elasticity less than 1. Up here we have elasticity greater than 1. And you can see why as we relate that to total revenue or total expenditures. Remember, revenue and expenditures are the flip side of the same coin. Revenues come to the firm via expenditures from consumers. Okay, let's apply this a little bit. In the last video on we talked about introduce the relationship between total revenue and elasticity. University of Nebraska football team, right? Raise the price. You've got an inelastic good, but now we know why they can't raise the price forever. You might have an inelastic good, but you just can't keep raising it and raising it and raising it forever and ever and ever, right? Because eventually it's going to become elastic eventually. And if you have an elastic good, you can keep lowering the price and revenues will go up. Well, up here. But eventually, we're going to hit unit elasticity, and if you keep going, the revenues are going to go down. So you don't want to lower your price too far. So airlines are a perfect. They are the masters of pricing, and you can pay a very different price from the person sitting right next to you. So what they try to do is they want those who are inelastic travelers. And everybody has their own different demand curve, okay? Their own individual demand curve. So those people who reveal themselves to the airline as inelastic travelers are going to pay a high price, right? Because they're inelastic. Higher price means higher revenue if you're inelastic. Those who reveal themselves to the airline as being elastic travelers are going to pay lower prices. Why? Because you lower the price on elastic people and you get more revenue. So, you're all thinking the same thing. How in the world do they reveal themselves? Well, by their travel habits, by their reservation habits. Okay, try this one. Let's say you're in business, your company has computer systems all over the world, and your job is to sell them and service them. And one of your biggest clients has, they've got major computer problems. Okay, you need to jump on a plane, like right now. Okay. And then you're going to fly out, fix the computer, and then fly back. Oh, boy, did you tell the airline a boatload of information. One, not very much notice between the time you schedule the flight and take the flight. And you don't stay very long, and you fly back. Oh, that reeks of inelasticity, right? They're going to pay. You're going to pay, all right, big time for that flight. Let's go to the other end of the spectrum. You're going to go to Disney World. You book your flight 2 months in advance, 3 months in advance. And when you get there, you're going to stay a few days. You're going to stay over a weekend. See, that's something business travelers don't do. You often get a big price break if you stay over the weekend. Not so much these days. Let me get to that. Eventually business travelers got tired of being taken to the cleaners, so things aren't so bad as they were. All right, but this several years ago, they used to stick it to them. But one of the big things was that business travelers don't stay over the weekend. Vacationers stay over the weekend. So you stay a week or so down at Disney World, then you come back. So what have you told the airline? You're pretty flexible. Your travel plans are pretty flexible. And they can't charge you that much because you know what? If they charge you too much, you're going to drive instead. But so a lot lower price. Everything else the same, okay? Everything else held constant. You're going to pay a lot less. That vacationer is going to pay. Now, a vacationer and the business traveler may be going the same place on the same flight. The vacationer paid a fraction of what the business traveler going down there, let's say down to Orlando to fix the computers, paid a fortune for his flight. Vacationer, not nearly as much. Now, I experienced this firsthand once. I was flying from Atlanta to Buffalo years ago. And I could have, if I wanted, flown up and back the same day, actually. And the price of that flight was $600 round trip. This was a Thursday, I believe. And if I stayed overnight and flew back on Friday, the price fell to $300. So what's the difference? Flying in and out the same day. Oh boy, this guy's desperate. Oh boy, this guy's got to have this flight. Yeah, stick it to him. By staying over a day, well, I'm a little more flexible, a little more elastic. Drop the price. But if I stayed over a weekend and flew back Monday, now what am I telling the airline? I'm pretty darn flexible. Hey, I'm not desperate. And the price of that flight was $150. Guess who stayed over the weekend and visited Niagara Falls? Oh, yeah. Now, like I say, that was in the, when was that? Late 90s. And discount airlines, I think that was pre-JetBlue, and some of those who used to be cheaper, now they're not really cheaper anymore. Whenever I fly, frankly, I find better prices on United and American, but they don't play this game quite to the extent they used to. But you still will get a better price if you book in advance. Now, if you book too far in advance, let's say you book 6 months in advance, they're not going to discount the flight that far in advance, not that much. They're not going to give away the store that far in advance. But, with some of the flying I've done, I've found, at least for me in the route where I go, it's about a month is about the sweet spot. But if I wait until a couple of weeks, they stick it to me pretty good. So another way around that is your return date. You can get around that by scheduling 2 one-way flights. And sometimes that'll work. But sometimes you can get a good price that way. Sometimes not. Sometimes you'll get a better price round trip. But it's more of a mixed bag. But the elasticity thing is still within. They're still subject to competitive pressures. The airlines have each other to contend with, and they can only get away with so much. But that's price elasticity of demand is very much at play with pricing of airline tickets.